This is a pretty typical angles question, where you're given a diagram, and on the diagram there are some angles that are marked, some angles that are not marked, and one particular angle, in this case the angle labelled with the X, that you have to find. If we just glance down at the bottom of the question, calculate the size of angle X, you must give reasons for your answer. So this is a pretty typical question, and let's be honest, it looks quite complicated because there's quite a lot going on. We've got an overall shape, we've got lots of lines within that shape, we've got arrowheads, we've got angles marked, A, B, C, D, and E, points marked. There's quite a lot going on. Now, I'm not expecting that we can answer this question straight away, but there are some things that we're going to notice about it first of all. The first thing we're going to notice is this bit here, diagram not accurately drawn. Now, that is code for you can't just measure the size of the angle. The idea is that if we were to pick any one of those angles, let's say the 120-degree angle at A, if you were to actually measure that angle with a protractor, you would find that it was close in value to 120 degrees, but not exactly 120 degrees. Close enough that it looks like it, but not enough so that it actually is, because that stops you from just measuring the size of the angle X. Now, if you can't measure it, that means we're going to have to get there some other way. And that's when we start to come to this bit at the bottom. You must give reasons for your answer. Because what we're going to do in these questions, ultimately, is we're going to use various properties of angles. And we're going to work through a step-by-step process, starting with the angles that we're given, using these properties to work out other angles, and then eventually being able to work out the size of the angle X. Now, in these questions more than any other, this phrase, you must give reasons for your answer, tends to make people waffle, and they end up telling a story, and they start writing at length. Well, first I noticed that the angles that were given to me were 120 degrees, 38 degrees, and 41 degrees. And then I thought, oh, well, I could find one of the other angles. I could use the 120 degrees at A and the 38 degrees at D, and I could find one of the angles at B. And I do that you end up just writing drivel. What this question actually wants you to do is work out the answer using the maths. Just do that. And then for each step you do, for each other angle that you work out, say how you know it is that angle. As in, write down which property of angles, which fact about angles that you know, led you to be able to work that one out. So each step in your working has to have a fact with it. Now, again, I am not expecting that we can answer this question straight away. The idea is that over the next few lessons, we are going to work out the properties that we might need and how they work. And for each property, we are going to come up with a stock phrase, a standard quotable phrase that we can write down if we use that property, if we use that angle fact. And then eventually we are going to build towards being able to answer this question. So by the time we've gone through all of the different properties, all the different rules, we have got all the tools that we might need to use, and we've got the quotable phrases that we can give, i.e. the reasons for our answer. And eventually we will be able to find the size of this angle labelled X. So let's have a look at some of those properties to start with.
Well, the first angle rule that we need to be aware of is actually one that we've already seen. We just need to firm this up a little bit and turn it into something that we can actually use every time. If I look at these two angles here, we've got one angle marked at 120 degrees and then another angle not marked. We should be able to work out the size of the unlabelled angle by looking at the two things together. What is true about the two angles together? Well, the two angles together make up a half turn. If we turn through the 120 degrees and then through the extra, we end up with a half turn. And a half turn is 180 degrees. So it must be that this angle here will be 180 degrees less the 120 is 60 degrees. And in fact, that relationship, that idea, is the first of our angle rules. That if we have angles that go together to make up a half turn, two angles or three angles or whatever, they will always add up to 180 degrees. So what we need is a quotable phrase to state that, and we state that angles at a point on a straight line add up to 180 degrees. It's worth mentioning this particular bit of the quotable phrase at a point on a straight line. Here are two angles, 40 degrees and 50 degrees. They are both angles on the same straight line, but why do they not add up to 180 degrees? It's because they don't join together to make a half turn. They are just two angles that sit on the same straight line. So the angles, the 2 or the 3 or the 4 or however many, have to meet at a point on a straight line. ABC is a straight line. Work out the size of the angle marked X. So A to B to C does make up a straight line. We've got two angles. We've got an angle here for 121 degrees and we've got an angle here marked X. We need to work out the value of X. Well, this is exactly what we've just seen. We've got two angles. They meet at a particular point, the point B, on the straight line. So to work out the size of X, we're going to do 180, take away the 121. That's equal to the value of X. 180 take away 121 is 59 degrees. Looking at X, while it is not drawn accurately, admittedly it doesn't say it's not, but these questions tend not to be, that looks like it could be 59 degrees. It's the right kind of size. X is an acute angle, 59 degrees is acute, so that seems reasonable. If we had to give a reason for our answer, we would just state exactly the reason we've just said, that angles at a point on a straight line add to 180 degrees. Nice quotable fact that we can use. Admittedly, this question doesn't ask us to give a reason for our answer, but if it did, that is exactly the reason that we would give, because that's the fact that we've used. That explains why we have used 180 and why we have taken away the 121 from it. Now, the second angle rule we need to be aware of is another one that we've already seen. So we have here three angles. We have a 150 degree angle, we have an 80 degree angle, and then we have a green angle that we don't know the value of. Once again, we should be able to work out the value of the green angle. How? Well, hopefully we will notice something about the three angles that are given to us there. The three angles together, the 150 degrees, the 80 degrees, and the missing green angle, make up a full turn. And we know that a full turn is said to be 360 degrees. Well, we have already got 150 plus 80 is 230 degrees out of the 360. So surely the green angle is just going to be 360 less the 230, leaving us with 130 degrees. And the size of that green angle is 130 degrees. How do we know? Well, we use the fact that the three angles together make up a full turn of 360 degrees. We could do with a quotable phrase to say this is the fact that we've used. So the quotable phrase we go with is angles at a point add to 360 degrees. Because there are three angles, they meet at a particular point here in the middle, and the three of them, in this case, although we can have as many as we like, do indeed add up to a full turn of 360 degrees. So angles at a point add to 360 degrees. Work out the size of the angle marked X. So we have three angles, and they meet at a particular point, which means we're going to use exactly that angle rule that we've just looked at. We have a 145 degree angle, we have the missing angle marked X, and we also have another angle that is not labelled. But we should be able to label that angle. How big is that other angle? Well, there is a box there, which means it must be a right angle, so it must be 90 degrees. So we should probably write that in. It's useful if we know the value of any angles that aren't labelled, we should probably write them in, because it helps to see all of the angles there numerically that we're looking at. But now we can use this angle rule. So we're going to do 360 less the 145 less the 90. It is your choice whether you do it as 360 take away 145 take away 90, or whether you add these two up first and then take that away from the 360. Whichever one works best for you, they will both get you the same answer. I'm going to add them first, but it is your choice which of the two options you go for. If I add them first, I'm going to do 145 plus the 90. Well, 145 plus 90 is 235. And then I'm going to do 360, take away the 235 to leave me with 125 degrees. And looking at that angle marked X, that looks like it could reasonably be 125 degrees. It is an obtuse angle, and so is 125, so that seems kind of reasonable. If we were asked to write down a reason, again in this question we are not, but if we were asked to write down a reason, we simply go for angles at a point, add to 360 degrees. Take a regular piece of A4 paper, held lengthways, landscape-wise if you prefer. We're going to run along that top edge, and I'm going to choose any point along that top edge. It really genuinely doesn't matter where I pick. In fact, try not to think too much about this, because the idea is that this is a random choice. So I'm going to pick this point here, for example. I'm going to mark it on. What I'm then going to do, from that point that I've picked, using a ruler and a pencil, I am going to join that point to this bottom corner, and then I'm going to join that point to this bottom corner. So I'm going to draw in the line like this. And I'm then going to draw in the line like this. What I have now done is I have cut my shape into 3 triangles. One large triangle here, and then 2 smaller ones up here. I'm now going to grab a pair of scissors and I'm going to cut along those 2 lines until you have 3 separate triangles. Choose one of the triangles. It really genuinely doesn't matter which one you pick. I'm going to go for the larger one, but this will work with any of them. In fact, you could try this with all 3, one at a time, to prove that this works. So I'm going to get rid of the 2 smaller triangles and I'm going to just keep the larger one there in front of me. Now what I'm going to do, with a marker pen or felt tip or highlighter, I'm going to draw the 3 angles of this triangle on the triangle. So there's one angle using that curve notation, there's another one using that curve notation, and then there's the final of the 3 angles using that curve notation. You can colour them in if you like, you don't have to, it doesn't really matter as long as you've marked the 3 angles on there. I am now going to, either using a pair of scissors or just by ripping the angles off, I'm going to rip those 3 angles off the triangle. And then I'm going to get rid of the middle bit that I don't want, just keeping the 3 angles. What I'm now going to do is I'm going to get my ruler again. And I'm going to position these 3 angles along the top of that ruler so that the curves make a nice smooth curve, and, or as close as I can anyway, and so that the 3 angles sit at a particular point. And look at that. When I do that, what do I get? I get half a turn, i.e. 180 degrees. It is particularly worth pointing out that I randomised the triangle, so I chose one of 3 that I generated, and that I chose a random point on this top line. So no thought went into this. I didn't design a special triangle that this would work for. And in fact, if I did this with the 2 other triangles, I would get the same situation at the end, where the 3 angles join together to make that half turn. In fact, if I did this with any triangle, no matter how big or small, I would get this happening. So this gives us the 3rd of our angle rules. The 3rd of our angle rules is that the angles in any triangle will add up to 180 degrees.